Okay, we pick up from yesterday with the mean value theorem. And the conclusion of the mean value theorem, it says that f prime of c is equal to f of b minus f of a all over b minus a. So it says, consider the following function over the given interval. I'm sorry, it should be in brackets, not parentheses. Use graphing technology to determine the value of c that satisfies the mean value theorem. So this function has a certain average rate of change over that given interval. And we want to find the point C where the derivative is the same as the average rate of change. That's what we're trying to do. Sounds confusing, huh? And since we don't really know how to take this derivative, the fact is we're going to need to use our calculator. So where do we even start? Okay, good. We'll take out the calculator. Now what? Okay, I go into y equals. I type in sine of e to the x. Okay, we can change the window, but there's something that we want to compute right now. Could we compute the right-hand side? Okay. Okay, we'll try it again. So we press sine, and then e to the x is going to be second natural log. We have an x, close the parentheses. So this is exactly what we did yesterday, folks. You started by plugging in what? The points. We can find f of 1, right? How do you do that? Plug in 1. Yep. Go into your table and plug in 1. So f of 1 minus f of negative 1 over 1 minus negative 1. Okay. What is f of 1? 0.41078 minus 0.35964. Divided by what? 2. 0.41078 minus, divide that by 2, and I get 0.02557. So, did I just do the right-hand side of the mean value theorem or the left-hand side? I did the right-hand side. How do we do the left-hand side? All right, when we left for lunch, there was some confusion about where we're at right now. So I need to know, is anybody confused about where we came up with the 0.02557? So what that means is the average rate of change over that time. So this is not what the function looks like, but suppose the function looked like that. That was at negative 1. That was positive 1, okay? The average rate of change over that given time interval is 0.02557. So that's the right side. Okay, so we just came up with this equals. Okay, so I'll put it on the other side. Okay, so 0.02557 is equal to, what do we do to get that? We take the derivative, right? Okay, now we don't know how to take this derivative, do we? So I'm going to teach you how to do a derivative on your calculator. You're not going to be asked to do this on an assignment. You're not going to be asked to do this on your test, but you will be asked to do this later on in the course. So I want to introduce it at this point. If you have a fancy-dancy new calculator, the operation is going to look different. Don't freak out. Just follow along, and I can show you how to do it on the TI-84 later. Okay, so I have y equals right here. What I would like to do is I would like to graph that derivative, okay? So first I'm going to write a statement. I would like the derivative of sine of e to the x, okay? Now you're going to learn how to find that derivative in about a month. Stop laughing, Jill. this is an equation I would like to solve, correct? So I'm going to turn that equation into a slightly different equation. The derivative of sine of e to the x minus 0.02557 is equal to 0. So I simply want to answer that equation. And that's not going to be that difficult to do. We go to our calculator, and we're going to take the derivative of sine of e to the x. Math. Scroll down to n derivative. N derivative means it's going to take the derivative of a function for a given x value, for a given variable. So as I have this, okay, we have to tell it what function we want. This is the function, correct? You can either type that in, or you can just type y1. Bars, V-A-R-S, that means variables. You can get to your y variables through there for your function and select y1. So this is going to take the derivative of y1, comma. What's the variable that we use in here? We use x. And then after we use x, we tell where we would like it to take the derivative at. Would we like to graph the derivative for just a single point, or do we want the entire derivative? We want the entire derivative. So we say x. Okay? And so this is going to take the derivative of sine of e to the x for the value x over all x values. So everything on the screen is going to show. Minus 0.02257. Oh, sorry. Got 5 in there. Thank you for catching that. And then as I go into y equals, okay, I'm going to take off the equal sign on the first one so I don't see it. And I'll zoom standard. And it's going to take a while. This is a very complicated thing we're asking our calculator to do. And the TI-83s don't have nearly as much RAM as the TI-84s. You can see the function that we start to get here. And what's our interval that we're looking at? -1 to 1. Okay. Does it look like the graph crosses the x-axis between -1 and 1? I'll zoom in as a box so I can see even better. So as I go to -1, and I'll scroll down, and I'll go over, I'm going to go past +1, and let's see if this graph crosses between -1 and +1, and that would be the solution to my equation. And it does, doesn't it? Okay. How do I find that spot? So I can calculate 0. Okay. And I'm to the left of that value. Press enter. Now I'm going to move to the right of that value. And I get x is equal to, I'm going to write it out to as many decimal places as I can, 0.4410538. A for the day. Who can tell me what the heck that even means? The slope at that point is equal to what? Positive 0.02557. The slope of my function at this spot, 0.441, is equal to that. That's what we're doing the mean value theorem. I'll check my answer just to see if I have it correct. As I go into y equals, I'll take the enter off the derivative, and I'll put it on sine of x, and zoom 6. This is what my function looks like. And I want to check for the derivative. How do I check for the derivative? Yep, number 6. And I want to check it at 0.44105368. And you can see here that I get, is that the value we wanted? Yeah, it is. Okay, so a more complex problem, is it beyond them to ask you a problem like this on the AP Calculus exam? No, It is not beyond them, but I would say that would be a more challenging problem. I would say that the success rate would be in the single digits for percent there. So, all right. So let's go to our table situations. Okay. This is what you're going to be expected to do on your homework assignment today. And this is, people definitely struggled with this first hour or second hour, but we weren't paying attention very well. So, but you guys are paying excellent attention, so I'm sure we'll get it. Okay, it says consider the following tables. Let f be continuous and differentiable over the interval. What does it mean to be continuous? Right? Not lifting up pencil, differentiable. No corners or vertical tangents or stuff like that. Very good. So it's a nice behaving function. And if that's the case, then the mean value theorem applies. The mean value theorem applies. So that's in play. So here's some table values. And it says, does there have to be a value c over the interval -2 to 3 such that the derivative is equal to -2? Well, let's watch what happens here, okay? So the function has a positive slope between -2 and 1, it looks like, right? And then after that, it looks like it has a negative slope, right? The question is, does it have to have a slope of -2? Let's check what the mean value theorem has to say. Let's try f of 3 minus f of -2 divided by 3 minus -2. What's f of 3? -1 minus 9 over, so I get -10 over 5, which is, oh hey, what do you know? So if the average rate of change is -2, does there have to be a spot where the instantaneous rate of change is -2? Yeah, that's what the mean value theorem guarantees. Yes. The mean value theorem, MVT. We've used 3 letters before, but they weren't MVT. What did we use? It's a MVT. IVT. The mean value theorem guarantees C in the interval -2, 3 such that f prime of C is equal to what? Yes, -2. That would get you some points on the AP Calculus exam. Now, here's what people struggled with during second hour especially. They saw -2 to 3, so they immediately looked at the whole part of the interval. It's not always going to be like that. Look at the next question. It says, does there have to be a value c in the interval -2 to 3 such that the derivative is equal to 0? So 2/3 of you are entirely confused, don't even know where to start, and 1/3 of you see something that stands out as something that we should recognize. Yeah, if you went from 9 to 16, was the average rate of change positive or negative? Positive. And as you went from 16 to -1, the change was negative. So basically, the function's going up, and then it's coming down. So does the derivative have to be 0 at some point? Yes. Now that's a little bit different. Okay? I'm not using, in that case, the mean value theorem. I'm using something else. I'm using the intermediate value theorem. The intermediate value theorem says if I went from a negative number, say, or if I went from a positive number, we'll say +7, and then I went to another number, say -17 or whatever, I have to cross over all the numbers in between there, don't I? Which includes the number 0. So let's figure out actually what our rate of change is. F of 1 minus f of -2 over 1 minus -2. I'm going to check the rate of change over the first interval. Because I'm going to show that it starts positive, and I'll do the next one to show that it's negative, okay? So what's that end up being? What do we have for f of 1? Minus 9 over, so we get 7/3, right? Okay, let's do another one then. Let's do f of what? 3 minus f of 1 and divide that by 3 minus 1. And I get, negative 1 minus 16 over 2. And so negative 17 over 2. Is 0 between those? So yes. Because negative 17 over 2 is less than 0, which is less than 7 over 3, the IVT guarantees the IVT. So the mean value theorem we can invoke if we come up with the actual rate of change. Does that make sense? We actually came up with negative 2, right? Here we're talking about, we're using multiple intervals to talk about crossing over a value. If you cross over a value, we're crossing over the value of 0. That's where the IVT comes into play. The IVT means we're gonna encounter every value in between those two, right? So the IVT guarantees C in negative 2, 3, such that f prime of C is equal to 0. Okay, let's look at these last two then. Okay, sorry, when I was doing I copied and pasted when I was writing my question. It should be 0 to 2. That's our new interval. Addition 1 of these notes. Okay, so it says, for this one, it says, does there have to be a value C in the interval 0 to 2 such that f prime of C is equal to 5? Why? Right there, right? As I increase by 1, I go up 5, right? So I didn't use the entire interval 0 to 2, but I used 2 points in that interval right there to come up with the average rate of change being 5, right? So f of what? 1 minus f of 0 over 1 minus 0. What's f of 1? 3 minus negative 2 over 1, so I get 5. That's exactly what we wanted, right? So it's saying the average rate of change is 5, so therefore the instantaneous rate of change must be 5 somewhere. So, yes. Whoop. The IVT, the MVT, thank you, good job. The MVT guarantees C in, what's the interval? 0 to 1. Yeah, 0 to 2 would be fine, but we can even specify 0 to 1, can't we? C in 0 to 1 such that f prime of C is equal to 5. Look at the last question. Does there have to be a value C such that the derivative is equal to 0? Yeah, so here I went up 5. Here I go up 3. So as a total, I went up 8. So does it have to be 0 at some point? No, I mean, the function might look like that. The function might look like that. Now, it's possible the function could look like that and that the derivative could be 0 somewhere, but we don't know that for sure. We can't guarantee it. No. The average rate is positive for all intervals. The mean value theorem does not guarantee C. does not. Okay. A little bit nicer when we just gave you those algebra problems, right? And I understand that. The AP Calculus exam asks you to look at the algebra, but also tables and also graphs. You don't have any new assignment. Just simply pick up with what you did yesterday. Okay. Have a great day.